Hi students, in this session let us try to understand mesh analysis. Anyway, we completed nodal analysis. Let me have a small recap of nodal analysis. So in nodal analysis, what is nodal analysis? Application of KCL. Okay, Kirchhoff's current law. What is KCL? Means algebraic sum of currents leaving at a particular node equal to 0. For example, if I have one particular node, okay, so in this particular node maybe many branches are connected, okay, so we are going to apply KCL here. Okay, currents leaving at a particular node is required. For example, if I have a current source of 3 amperes, application of KCL is direct because current flowing through current source is known. Okay, basically one thing we have to understand about passive elements and active elements. In passive elements, from currents voltage can be found, and from voltages currents can be found, because there is a definite interrelationship between voltage and current. Okay, now if you think of active sources, active elements, for a voltage source voltage is known but current will be decided by connected circuit. For a current source current is known but voltage will be decided by the connected circuit. So for example, if I want to apply KCL with a current source, it is going to be direct. I'm not saying easy or difficult, but it is direct. For example, if I have voltage source here, current leaving through this voltage source, how that will be decided by the circuit. So means application of KCL or nodal analysis is indirect with voltage sources, direct with current sources. But anyway, we got the conclusions that if you have more and more voltage sources, it is actually easy for the calculation in nodal analysis. Anyway, once our present discussion is over, then we are going to compare mesh and nodal, then we are going to solve problems. In the problems, means each and every problem we are going to see how many meshes will come, how many nodes will come. Okay, how many mesh equations has to come, or how many mesh relations will come, how many nodal equations will come, how many nodal relations will come. Okay, depending upon that we are going to compare and we are going to decide whether to choose mesh analysis or nodal analysis. Okay, anyway, let us think of mesh analysis now. In mesh analysis, about the mesh, already I have given some idea previously also. For example, this is the circuit. Okay, in this circuit how many meshes are there, or what is meant by mesh? Okay, mesh is a closed path inside which there should not be any closed paths. For example, if I think of this current path as I1, is this a mesh or not? Yes, this is going to be I2 mesh, because inside there is no closed path. For example, if I consider this, that is not going to be mesh, we are going to call it as loop. Okay, so point here is very simple. Mesh means inside which there should not be any closed path, because mesh analysis means that application of KVL. What is KVL? If you see, algebraic sum of voltage rises or voltage drops in a closed path independent of path followed is going to be 0. So I can apply KVL like this also, but in mesh analysis we are going to apply like this, mesh. Okay, I3. So how many meshes will be there? 3 meshes will be there. 3 equations has to be written, and those 3 equations we have to solve in order to find I1, I2, I3. Because means once you find I1, I2, I3, automatically you will be able to find current flowing through this branch, or voltage across this branch, or power absorbed by this branch. Anything can be found. Means that analysis is completed, we can say. Okay, now it means application of KVL in a closed path inside which there should not be any closed path is nothing but mesh analysis. Okay, now let us think of voltage source and current source, because sources are different. For example, if I have one voltage source here of 5 volts. Okay, if you try to apply KVL, Kirchhoff's voltage law, around it, it is going to be direct, because voltage rise or voltage drop is known. Okay, for example, if I have a current source, of 5 amperes. Okay, in applying KVL, maybe voltage across this I know, voltage across this I know, but voltage across current source, it is not direct. Okay, I'm not saying again easy or difficult, but application of KVL with voltage source is direct and with current source is indirect. Which is easy, which is difficult, we will see at the end of the session. Okay, now let us try to apply KVL for this, mesh analysis for this. Now if you observe the same circuit, okay, the same circuit we got from nodal analysis. Okay, in nodal analysis what I have done, in nodal analysis at starting I have taken the same circuit with only current sources. Okay, with all current sources I have taken, and we tried to solve, we tried to write equations at least. After that, gradually each and every current source I converted into voltage sources, and we made it easy actually by keeping voltage sources with respect to reference, with respect to non-reference, something like that. Okay, anyway, now I have taken all voltage sources. The moment I have taken all voltage sources, application of KVL is going to be direct, because all voltage source only there, no? Okay, so all the sources, whatever are the sources are there, all the sources are voltage sources, means that application of KCL is going to be direct, KVL is going to be direct. Now let us see. Anyway, for future purpose, we have to change in this and we have to modify. So let me have a copy of it. Okay, now let us see. See here in this mesh analysis, how many meshes are there? 1, I1. Of course, all currents can be taken in this direction or in this direction, doesn't matter. I2 and I3 and I4. Okay, now 4 unknowns are there, so means we should be able to write 4 equations such that by using 4 equations 4 unknowns can be solved. Okay, that is going to be mathematics. Now anyway, let us try to write it down. For example, let me start from here. Okay, if I start from here, KVL, okay, don't think of Vx. What is Vx? It's going to be controlling variable. Even if you write Vx, for example, if I write plus, I touched first, if I write plus Vx, okay, if I write plus Vx, then what will happen? Vx should be, everything should be named in terms of I1, I2, I3, I4 only. So Vx should be written again in terms of I1, I2, I3, I4 only. Okay, now if I start from here, current is entering here, I1 is entering here, so here plus will be there, here minus will be there. Current entry point if you refer. So 1 into I1 is going to be the voltage, and in going like this I am going to touch plus first. Okay, I have to use plus, already convention is fixed. So 1 I1 plus, now let me think of red color. Okay, so 1 I1 entered in this current, and after that in this direction how much is the current? In this direction how much is the current? Because if I consider in this direction current, plus will come here, minus will come here, such that in my equation I'll be able to directly use plus signature. Okay, so point here is how much is the entering current here? Current entering in this direction is I1, current going opposite direction is I2. So how much is the entering current here? I1 minus I2. So plus 2 into I1 minus I2. Okay, plus, because plus I touched here. Okay, so the moment I am using plus means that current going in this direction. How much is the current going in this direction? I1 in the same direction of I1 and I2 in opposite direction. So total downward current is going to be I1 minus I2, and resistance is going to be 2. And after that minus, why minus? Because I touched minus first. It's a voltage source direct. So minus 4ix equal to 0. Okay, everything should be in terms of I1, I2, I3, I4. Okay, for example, Ix should be renamed in terms of I1, I2, I3, I4. Where is Ix? Ix is here. Ix is in downward direction. Downward direction current is how much? I1 minus I2. So Ix equal to I1 minus I2 is going to be the first equation. Now let us speed up the process. Let us start from here. Okay, now in this case, see, I2 is going in this direction. So reference let me take in this direction. In this direction how much is the current? Okay, so I2 is going in this direction, I1 is coming in opposite direction. So net current going in upward direction is going to be I2 minus I1. Because if I consider I2 minus I1, I can start plus minus here. And I'm going to touch plus first. So in applying KVL, I can write plus. Okay, so plus 2 into I2 minus I1. 2 into I2 minus I1. Okay, because I2 minus I1 is the current going upward, I1 minus I2 is the current coming downward. Okay, anyway, I2 minus I1, I came to here. After that, I'm going to touch plus first. Use plus directly 3. And after that, come back here because in a closure path. And after that, current entry in this point, in this direction is how much? I2 minus I4. Okay, current going in this direction is I2 minus I4. Okay, so I2 minus I4 into 5 is going to the voltage drop like this. Okay, so voltage drop, if you have to touch plus first. Okay, you are thinking that way. So if you are touching plus, means that I can use plus there. Now definitely I can use plus provided total current is in this direction. How much is the total current in this direction? I2 minus I4. So plus 5 into I2 minus I4 equal to 0 is the second equation. Okay, now what is the third mesh? Third mesh. Now if you see the third mesh, let me start from here. Okay, so directly let me speed up the process. 6 into I3, 6I3, and after that I am going to touch plus first. So plus 4ix, plus 7 equal to 0. Again Ix should be I1 minus I2, already we know. So this is the third equation. Now what is the fourth? Let me start from here. I touched minus first, so minus 7. After that plus 5 into I4 minus I2 is going to be the net current going in this direction, right side direction. So plus 5 into I4 minus I2 plus 8Vx equal to 0. This is the fourth equation. But what is Vx? See here. What is Vx? Because everything should be in terms of I1, I2, I3, I4, such that means by using 4 equations, 4 unknowns can be found. Now, what is Vx? This is going to be the dependent variable. How much is the dependent variable magnitude plus here? So current entering in this direction should be considered. Current entering in this direction is I1. So I1 into 1 is going to the voltage drop across 1 ohm resistance, and polarity is also proper. So what is Vx here? Vx equal to I1 or 1I1 if you want. Okay, so these 4 equations has to be solved. Frankly speaking, it's difficult. It's difficult, right? So anyway, these 4 equations, you know how to do that by matrix and all. Okay, so these 4 equations should be solved, and I1, I2, I3, I4 should be found. Basically it is lengthy process. Okay, though application of KVL is direct with voltage source, but process is lengthy. Let us see. Now I have taken same problem. Okay, let me convert few things, because application of KVL is indirect with current sources. Okay, so for example, let me change this to 3 amperes. 3 amperes. Okay, then what will happen? Let us see. See here again, I1, I2, I3, I4. This is going to be I1, this is I2, this is I3, this is I4. Okay, here if you observe, I1, I3, I4 equations will not change. But anyway, let me write a bit fast. Okay, let me write a bit fast. First mesh equation, let me start from here. So 1 I1 plus 2 into I1 minus I2. Okay, I1 minus I2 minus 4 Ix equal to 0. Okay, so that is one equation. And second mesh. Now let us start from second mesh. For example, I am starting from here. Okay, so how much is this resistance? 2 ohm. Okay, 2 ohm into I2 minus I1. So 2 into I2 minus I1. Okay, so here 2 into I2 minus I1 is going to the voltage like this. Okay, so I got the voltage here, and after that means I started from here, I reached up to here. Now how much is the voltage across current source? How much is the voltage across current source? Okay, because in application of KVL, voltage rises or voltage drop should be there. Right? Now, how much is the voltage across this? We don't know. Then what to do? Basically, why to do this? For example, what is the purpose of us doing all these equations? Okay, in order to find I1, I2, I3, I4. Right? So 4 equations has to be solved. Now, for example, how much is I2? Is going to be 3 amperes only now. So why to write equation directly I2 equal to 3 amperes? So one equation is gone. Getting my point, right? So completely this equation is gone. Okay, now after that, for example, second is over, third it is going to be the same. How much is this? Let me start from here. 6I3 plus 4Ix plus 7 equal to 0. This is going to be the third mesh. Okay, now let us think of fourth one. Let me start from here. Minus 7 plus 5 into I4 minus I2, 5 into I4 minus I2 plus 8Vx equal to 0. So how many equations I got? How many times I had to apply KVL? How many times I had to apply KVL? First time. Here in the second, I did not apply KVL. Second equation where I applied KVL. Third equation where I applied KVL. So here I did not apply KVL, but that is going to be the direct relation. So point here is very simple. If I have one current source, I need not apply KVL once. So with current source, application of KVL is indirect, but it is easy. Because I didn't apply KVL here at all. So means if I keep directly I2 value here 3 amperes, or wherever you got I2, if you replace I2 with 3 amperes, now the present equations will be only 3. So the moment you have current source connected in the outermost loop, I am not saying mesh, if for example, if current source is connected to the outermost loop to the concerned mesh, I need not apply KVL. Okay, now if you connect this particular thing to nodal analysis also, in nodal analysis at one point we did not apply KCL, where if a voltage source is connected with respect to reference, okay, if a voltage source is connected with respect to reference to the concerned node, means we need not apply KCL at all. Similarly here means you can make a note of it. When current source is connected to the outermost loop, because outermost is going to be loop, because inside there are some closure paths. Okay, now if any current source is connected to the outermost loop, I need not apply KVL to the concerned mesh. Okay, means that is going to be direct relation. Okay, the difficulty level is going to be reduced. Now let us take the same network and let us modify and see. Now let us try to modify the previous circuit. For example, let me change this to current source. Okay, now for our future reference, let me have a copy of it. And let us try to do our activities now. Now if you observe how many current sources are there to the outermost loop, 1, 2. So these 2 times I need not apply KVL at all. Now the complete 4 mesh circuit will become only with 2 by 2 matrix. Okay, so let us see here. This is I1, this is I2. Just let me write I3, I4. Okay, so what is the relations now? Because this current source is connected to the outermost loop, so I2 is going to be 3 amperes. I2 equal to 3 amperes. Gone, one relation. Okay, I4 equal to 8Vx. I4 equal to 8Vx. It is going to be second relation. So I need not apply KVL in the second mesh and also in the fourth mesh. Now let us see in the first and third. Okay, in the first, if I try to apply as usual same, let me start from here. 1I1 plus 2 into I1 minus I2 minus 4ix equal to 0 is the third equation. Okay, now if you see first is over, next third one we have to apply. Let me start from here. Okay, 6 into I3 plus 4ix plus 7 volts plus 7 equal to 0 is going to be the. So the moment you have two current sources, especially in the outermost loop, then we did not apply KVL to those two concerned meshes. Now what is Vx from here? What is Vx? Where is Vx? Here. Okay, so moment this is Vx, that is going to be 1I1. Okay, now let us think of somewhere Ix. So what is Ix here? What is Ix? I1 minus I2. I1 minus I2. Of course, how much is I2? 3 amperes. Okay, so if you observe now, the situation is became very easy. Okay, why? Because current sources. So the conclusion is very simple. What is that? Application of KVL is direct with voltage sources, indirect with current sources, but it is advantageous because we can shorten the calculation process. Now let us see the same diagram, whatever we have taken till now. Okay, now let me change few other things also into current sources. For example, let me have this is 4ix is same, this is 4ix only, so this is current source. Now let me change this voltage source also into current source. 1 2 3 4 5 6 7, yeah, 7 amperes current source. If you keenly observe, this was the circuit when we have taken before starting nodal analysis, right? Before starting nodal analysis, this was the same circuit we have taken. Okay, so again from mesh analysis we are merging back to nodal analysis. Okay, so see here, all are current sources. Now let me compare just like that. Okay, so here if you try to apply nodal analysis, how many nodes are there? 5. Reference node, 4 equations. Now if you try to go ahead with nodal analysis, 1 2 3 4, because already we know that whatever may be the node to which maximum connections are there, we are going to consider that as a reference node. Okay, so with nodal analysis, if you take this as a reference, 4 nodal equations will come, detailed nodal equations will come. Okay, now if you go ahead with the same circuit, mesh analysis, how many meshes are there? 4. Now 4 meshes are there, it's fine. But if you think of, for example, current sources, how many current sources are there? 4. So all 4 will be relations only. Getting my point, right? All 4 will be relations only. So in this circuit, I need not apply KVL at all. Okay, so the same circuit with nodal analysis would be difficult because it will take lengthy process, but with mesh analysis it will be easy. For example, let us think of I1, I2, I3, I4. Okay, now what will happen? For future reference, let me have the copy of it. Yes. Okay, now let me write equations. Okay, now what is I2? In order to find I1, I2, I3, I4, I need 4 equations, right? So how much is I2? Equal to 3. How much is I4? Equal to 8Vx relation. Okay, so how much is this particular thing? So I4 minus I3 equal to 7, no? I4 minus I3 equal to 7. Third relation. Okay, now here I3 minus I1, because current source direction is this direction, I3 minus I1 equal to 4ix. I3 minus I1 equal to 4ix. 4ix is going to be the fourth relation. Okay, what is ix? You know, ix is nothing but I1 minus I2. Okay, now what is Vx? Where is Vx? Yeah, Vx equal to 1 into I1, that's it. Okay, so the same network, if you try to apply nodal analysis, 4 equations has to be solved. But with mesh analysis, nothing. I need not apply KVL at all. So means if you have more and more current sources, application, actually roughly I'm speaking now in a course, it is not fine tuning. Gradually once we get the problems and all, we are going to fine tune that. Okay, for example, if you have more and more current sources, then maybe application of KVL would be better or mesh analysis would be better. Okay, if you have more and more voltage sources, okay, more and more voltage source in the sense more and more supernodes can be formed and more times KCL need not be applied. So if you have more and more voltage sources, our nodal would be better. If you have more and more current sources, mesh would be better for time being. Okay, now let me think of in the same circuit, let me convert this into 8 ohms. Okay, now let me apply mesh analysis. Now how many meshes are there again? 4 meshes are there. How many current sources are there? 1, 2, 3 current sources. Okay, see, this is actually a wonderful problem. Okay, so 3 current sources are there, so 3 times relation should come. Out of 4, in the sense, only 1 time you should be able to apply KVL. Okay, now let us see. Perfect. Okay, now let us see. Means directly let me write relation I2 equal to 3 ampere. Okay, I3 minus I1. I3 minus I1. I3 minus I1 equal to 4ix. Okay, so this is first relation and this is second relation. Now let us think of third relation. I4 minus I3 equal to 7. I4 minus I3 equal to 7. This is going to be the third relation. Now let us think of relations are over. Now we should be able to write the equations. Okay, so let us start from equation. Means that nothing but applying KVL. Now if you try to apply KVL, okay, so if you try to apply KVL, let us start from here, for example. Okay, so you started applying like this. KVL, you are starting applying like this. What is this? Current source. Okay, so the moment it's a current source, from here to here, KVL. Okay, voltage rise or voltage drop, you will come to know. Here to here, you know, but here to here, you don't know what to do. Actually, means in our nodal analysis, what I have taken, Ix I have taken. Okay, for example, if I take voltage across this is Vp. Okay, so let me a bit. Hope you are able to see now. Okay, so for example, means voltage across this is Vp. Okay, now if you try to apply KVL, means this voltage you will be able to write, this voltage you will be able to write, this voltage you don't know, that's why you are writing in that terms of Vp. Now while applying KVL here, again here plus Vp will come, here minus Vp will come. So combinedly only one equation will come. Anyway, the most, what do you say? Of course, if you extend this, anyway you will get the same conclusion. So let me do one thing. Anyway, from here to here is over. Now it's a current source. So the moment current source is connected between first mesh and third mesh. Okay, current source is connected between first mesh and third mesh. So jump from first to 3. Means that it's going to be loop now. Now it means, because what is KVL? KVL means that independent of path followed in any closed path. So I can take closed path like this also, I can take closed path like this also. KVL is going to be valid because conservation of power. Now let me jump from 1 to 3. Now let me start applying here. Again current source is there between third and fourth. So let me jump from third to fourth. And in fourth let me continue applying KVL. Done. One equation is done. Okay, of course people call it a super mesh analysis, but that is not required. If a current source is connected to the outermost loop to the concerned mesh, I need not apply KVL at all directly. Now one more thing is, if a current source is connected between X mesh and Y mesh, okay, if a current source is connected between X mesh and Y mesh, so means from X to Y combinedly apply one loop analysis or apply KVL, problem is solved. Okay, now let us try to write this. Maybe let me start from here. Okay, so I1 is flowing like this. I1 into 1 I1. Okay, after that from here to here 2 into I1 minus I2 plus 2 into I1 minus I2. After that I have to jump from here to here. Again current source, jump from here to here, and again current in this direction is going to be I4 minus I2. So plus, what is the resistance value? 5 ohm. So 5 into I4 minus I2. Okay, plus 8 into I4. Plus 8 into I4. After that, plus 8 into I4. After that, 6 into I3. Loop is closed. plus 6 into I3 equal to 0. This is the fourth equation. Okay, now let us compare this with nodal. For example, if I use nodal analysis here, how many nodes are there? 5. Reference node. 4 equations are required. If I go ahead with nodal, 1 node, 2nd node, 3rd node, 4th node, so 4 times I have to apply nodal. 4 times I have to apply nodal. But if I go ahead with mesh analysis, what is the advantage here? The advantage is 3 relations, because current source relation, combinedly only 1 equation. So application of KVL is better if you have more and more current sources, such that we will be able to apply super mesh analysis. Okay, so immediately after this, it means just keep these as basics, because we don't get in GATE or ESE 4x4 matrix. Okay, our 4 meshes are 4 nodes, we may get 2 nodes or 3 nodes maximum. Okay, or we may get 2 meshes or 3 meshes maximum. So in GATE or IES, we will see exploring them from now onwards. Thank you.